sir. He is a former professor of Center of Energy Studies, IIT Delhi. He has completed his PhD from Banaras Hindu University, Varanasi in 1976. He joined as a research associate at IIT Delhi in 1978. He is holding a position of professor at Center of Energy Studies, IIT Delhi since 1997. His international experience includes various program contribution and participations in different countries for various fields of study. His research interests reflect in his wide range of publications in national and international journals. He published more than 400 research papers in different national and international journals, and he is the author of 8 texts and reference book on solar energy, greenhouse, and passive heating, cooling, and renewable energy resources. He is awarded of National Hariom Ashram Prerit S.S. Bhatnagar Award in 1982 for his contribution in the field of solar distillation. He has been nominated for International IDEA Award for his work on solar distillation in 1992. He has supervised more than 40 PhD students in various research areas of interest. His current area of research interest are solar energy and its application in solar distillation, passive heating cooling of building, controlling the environment greenhouse, water air heating system, crop production and drying, renewable energy resources, energy analysis of all the system, techno-economic analysis, hybrid PV thermal system, clean environment, and rural energy, etc. So now I would like to call Dr. G.N. Tiwari sir to deliver his expert talk on greenhouse sustainable technology for rural application. Dr. G.N. Tiwari sir.
Can you guide me how to load my presentation? Hello?
Presentation, you share present now.
There is no any sharing arrangement.
Okay, so first you open your PowerPoint presentation in your laptop.
I have already opened.
Okay, now then you go to present now.
Now I should go to the present now.
Okay, so you got.
Okay. Are you seeing something?
So you got the. A window.
There is no any.
A window.
There is a sign up present now, right? So I should press that one, right?
And a window. So sharing window is open.
There is no any sign of sharing the window.
And share an application window.
No, there is no provision here. I am not seeing anything.
Okay. So first.
Now.
Sir.
No, I've already.
Okay. First, you click on your presentation.
I have clicked already presentation. Okay.
Okay. Then after you go to present now.
Pardon? Present now.
And then open into a window.
Okay. I will just go present now, right?
Then
your entire screen. Am I right? Window. Yes, window I just gone.
and then you see your
Share.
uh,
There is a share. Share. Yes, I've just put share.
yes,
Anything visible?
yes, sir. Now it is start. No, okay, now, sir, you open your presentation.
Yeah, it is visible.
It is visible, but it is a entire screen visible.
The screen is visible, sir. You only need to start the presentation.
Okay. Full screen there, right?
You start your presentation. Once we are able to see that, then we can continue with our session.
Okay, now presentation is visible to you. No, presentation should be visible to you or not?
Not visible, sir.
विजिबल नहीं है, कैसे विजिबल करेगा? उसको पूछो जरा
धीरज है
वाले आता था शेयर के इसमें नहीं रहा।
गूगल मीट खोले हैं सर?
हाँ,
गूगल मीट खोल?
गूगल है, गूगल ऑलरेडी खोल चुका हूँ। कहाँ से सब यही सब हमको नहीं आता है, सब जो है। अब यहाँ जो है तुम बात करो।
हेलो, हेलो, हाँ सर, आप एक मिनट, विंडो खोल गया। विंडो पर किस पर क्लिक करना है सर? शेयर पर, शेयर पर। पीपीटी हो तो गया, स्टार्ट रहा। यू आर प्रिपेयरिंग टू प्रेजेंटिंग टू एवरीवन। मीट में ही तो खोले हैं सर।
अभी सर अभी आप अपना प्रेजेंटेशन खोलिए। आपका स्क्रीन हमें दिख रहा है। अभी प्रेजेंटेशन ओपन करिए सर।
अब यहाँ कहीं लिखा नहीं है, there is no writing presentation open. यहाँ this is hide is coming, stop sharing is coming, and
Yes,
meet.
वही मीट डॉट शेयरिंग इज अ विंडो। हाइड 1 मिनट प्लीज।
हाँ,
अब बोलिए सर, इसमें क्या बोले हैं? जैसे मान लीजिए मीट पर खोल दिया, ठीक है?
ये ठीक। आपका स्क्रीन हमें दिख रहा है। अभी आपको खाली प्रेजेंटेशन ओपन करना है। आपने जहाँ पे भी सेव किया है वो प्रेजेंटेशन ओपन कर दीजिए फाइल।
ये वाला है यार, लाल वाला।
इसमें हाँ, मैं ओपन तो किया सर। यू आर प्रेजेंटिंग टू एवरीवन, क्लिक हियर टू रिटर्न द वीडियो कॉल। अच्छा ठीक, मैं क्लिक कर दिया वीडियो कॉल के लिए। यू आर प्रिपेयरिंग टू एवरीवन, यू आर प्रेजेंटिंग पे क्लिक करना है सर। ओपन हो रहा है। Okay, sir. Thank you.
Okay, now, sir.
Okay.
Okay, sir. Now you will start.
Sir.
Now it is visible.
Yes, it is visible, sir. Now also
Now
full screen, if it is
इसको
possible.
इसको हटा दो. हाँ, yes, it's possible. यार.
फुल स्क्रीन लोअर साइड पर आपका एक
Yeah.
है, तो फुल स्क्रीन भी कर सकते हैं.
अरे मैंने यही सब पता नहीं क्या बोल रहा है.
Okay, sir.
Now it is okay.
Yes, okay, sir. Now start.
अगर नहीं होगी
Now I should start.
Yes, sir.
Okay. Now I am just starting. Okay.
Okay,
So
okay.
good morning to everybody. Hello. Good morning to everybody.
Good morning, sir. Good morning.
Good. And now I am going to present the greenhouse sustainable technology for rural applications. And here, when we talk of the greenhouse technology, then it is necessary to know about what is the greenhouse effect. So for that, there are two types of the greenhouse effect. First is the global greenhouse effect, which is very much related to this topic of today's discussion. And everybody might be knowing about the position of the sun and earth. And in between these two planets, there is a layer consists of many light gases like carbon dioxide, carbon monoxide, ozone, oxygen, etc. And these lightweight gases were erupted from within the formed between sun and the earth. In our solar energy, we call the atmosphere. And this atmosphere might have formed millions years back by getting together from all the emitted earth. Now, if you just see the solar energy which is coming from the sun, the global average temperature of the sun is supposed to be 6,000 Kelvin. And the average temperature of the earth is roughly about 300 Kelvin. So most of the people might be knowing the Wiens displacement law, and that Wiens displacement law is lambda T is equal to 3000. Lambda is in micrometer, T in Kelvin. If you apply this formula to the sun temperature, where temperature is 6,000 Kelvin, then lambda will come roughly about 500, 0.5 micrometer. But when you apply this Wiens displacement law for the earth, then lambda will come roughly about, average value is 10 micrometer. Now everybody might know that 0.5 micrometer is much less than the 10 micrometer. This atmosphere is a very unique property. And the unique property transfer it will allow to go atmosphere only allow the radiation 3 micrometer. And of thing, a short radiation toward the element how much person is going, and finally this is absorbed by the earth. And surface temperature is the average temperature of the earth is roughly about 300 Kelvin. That means the average radiation which is emitted from the earth is 10 micrometer. And that is the another property of the atmosphere, that this atmosphere does not allow this 10 micrometer radiation to acceleration. That means it has two purposes. First purpose is it transmits the short wave radiation, does not allow the long wave radiation. So in that case, what will happen? The air between the atmosphere and the earth will get heated. And most of the world might be the earth initially was covered by the ice and the land. And pressure is by the scale. And so you still consider the H2O. So what happens? This H2O, when the photon of the solar radiation can this two. So H2 and O is isolated. And in that case, what happens? This H2 which is coming from water interact with the carbon dioxide of the atmosphere, makes hydrocarbon. That is how the algae was formed. Algae was formed and the color of the algae was green. So because of that, whole this phenomena is known as greenhouse effect, global greenhouse effect. And similar thing is also observed in a car when all the windows are closed. What happens? The glass, transparent glass, transmits the short wave radiation inside the car, which is absorbed by the seat cover in the other part, and it converts into long wave radiation. That means you can say that the any surface, any surface, any surface which is absorbing the solar radiation means that surface is converting the radiation from short wavelength to long wave radiation. And also the glass has the similar property of the atmosphere. Glass does not allow to escape the long wave radiation. Because of that, you feel warmer inside the car when the window is closed. This is the brief introduction because I am going to use the plastic in solar thermal technology. This greenhouse concept is always used. Without understanding this phenomena, you cannot understand any solar thermal technology, any photovoltaic system, because glass is the main component of all the technology. Now I will come on the, you can say this, my topic, and the topic, as I mentioned you that it is the sustainable greenhouse technology. My lecture will divided into three parts. First part is related to the growth of the vegetable in the part cultivation, in the field cultivation, and the comparison. Second part will be the fish production inside the greenhouse and outside the greenhouse, because the fish production is significantly affected in the winter condition, and because of that, price of the fish is more. And the third part will be how this greenhouse effect can to jaggery, because dry the jaggery and packing it, and then it durability becomes more. Otherwise, if you just put the jaggery in open way, it starts melting, because it is made from the sugar juice, which is most part is the water. So sustainable, I will just skip this thing because otherwise I'll just show you all these slides. You can read it. And just when I was in IIT Delhi, so during that period, we have created a solar energy park. It is a glimpse of this activity. We have the mud house also, and solar active, still also greenhouse for aquaculture, and the passive solar still, and PV greenhouse agriculture. Because any solar system has a very property. It is a very strong function of the climate. Climate of the world is more or less same. For example, Europe. In Europe, you always require heating. You don't require cooling there. So design of any solar system is very simple, very easy to design. That means greenhouse design for the Europe is very simple. Because of that, every house has a small greenhouse for floriculture and other product. But when you are having the very warm condition throughout the year, just like Middle East, then also it is very simple to design any solar system from cooling point of view. But when you go for a composite climate, for example, North India, I think Gujarat also comes in that way, that when you are feeling harsh cold climatic condition and harsh warm condition, then you have to decide whether number of days for the harsh condition, warm condition is much, much more than winter or vice versa. So, as you know that in the northern part of India, the summer splits number of days, maybe 160, 180 days. And winter is only spread about a month. So, if you ask my opinion, then all the solar system point, not the wind, energy in the heat. These are some are there from and this solar energy park has the following, you can say this PV standalone system to supply the electrical power to the mud house to operate the fan and compute other things. Water pumping, it is also based on the solar power generation. Also the in a mud house, we have the electrifications to provide the bulb and other thing in the night time. Also, we have earth air heat exchanger for heating the cooling the building and experimental setup for the hybrid PVT thermal performance. But I'm not going to discuss more this. I will come on my topic of this thing. Then a solar distillation unit also there, rain harvesting, all these things, and greenhouse. The majority I'm just going to cover about the greenhouse technology. We also have we used to have solar radiation measurement, pyranometer and other things. I'm just saying. Actually, when I was in IIT, then we also felt shortage of the electricity, particularly during the daytime. Actually, I'm talking up to early 2000. Then it becomes very difficult to conduct the experiment, particularly on the solar energy, how you can measure the temperature, other things. And then it was decided to create a solar energy park, which should be self-sustained in all respects, including water, vegetation, and all the plant. So no one was actually at that time believing that there can be water pumping based on the solar energy. Few people. Then Professor Joshi, who was a Director General of CSIR, visited and see this how much water can be pumped, and it was found to be much better than expected. Now I will just. Now, when you are going to grow any plant in a greenhouse, so basically the comparison should be done from the outside. In outside, it is called the field cultivation. In a field cultivation, for every plant, for every crop, the distance between the two crops is optimized. So we just taken the cucumber and inside as well as the inside greenhouse. In a greenhouse, also we have the drip irrigation. Now, the greenhouse can be classified into the low cost, which is generally bamboo is used, and the life of that greenhouse can be 4 to 5 years, not much more. And then you can have the medium category of the greenhouse where the GI pipe has been used. Here the life of the plastic sheet maybe 4 to 5 years, but the structural life can be 20 to 30 years. So if you have to plastic over it. Now, another important thing which was observed in the greenhouse for composite climate, that you have to run the appliances. For example, for cooling purpose, evaporating cooling system is supposed to be used. As I mentioned you, that during the daytime, all solar thermal system work, or photovoltaic system works. So we need evaporating cooling system. And to run the evaporating system, unless you don't have the electrical power, you cannot do it. Then we have got this opaque PV module we purchased from Central Electronics and integrated to the south direction. And actually, for the PV system is different than the greenhouse system, but it was a 45 inclination, which was not correct at that time. Later on, we have corrected because it depends upon whether you want the annual output, winter condition or condition, and then accordingly the greenhouse also, which is roughly about latitude plus minus 15. Plus refer to the winter and minus refer to the summer. And generally, when we talk of, you can say, when I was in ADIT, then we talk of the growing a cucumber, then question comes whether it is economical or not. So at that time, frankly, we should say that medicinal plant we should grow, which can give the high return. So also, just the has a uniform heating throughout the year. So if you are having the greenhouse there, it is most effective. And for kind information, for the Leh, one has to transport vegetable from Chandigarh to Leh by helicopter. But now, using the technique, because inside the earth, they channel roughly about 3 to 4 feet deep, and over that they have the arc type, you can say a greenhouse where the people can grow. So in that case, the vegetation is heated on the top by greenhouse effect, and also the earth heat is used to heat the temperature. Second, the greenhouse also reduces in the night time because of the glazing effect. So it serves 3 purposes, and they are having the production of the vegetable in so huge way that now they are transporting vegetable from the Leh to Chandigarh. Let's see. As I have shown you that we have 2 types of the cultivation inside the greenhouse, part cultivation and field cultivation. The difference between these two is that part cultivation acts independently. There is no need to optimize the distance between the 2 crops. But in the field cultivation, it is mandatory to optimize, otherwise root media interact each other to affect the production. Just see, for comparison purpose, we have placed the things outside, inside. Let's see, on the right hand side, it is field cultivation, and the left side is part cultivation. And here we have, just for the comparison purpose, 20 plants in the field cultivation and 20 plants for the part cultivation. We have just given. We have seen that in the winter condition, the production in the greenhouse is much more than the outside. Because outside there are some plants under the caps, the product of the summer condition. And if condition greenhouse, it should be either off-season production or pre-season or post-season. 3 types of the cultivation can be done. Then you can have the high return. Only timing of the sowing and transplantation should be adapted to get the maximum yield inside the greenhouse. Now just see, Actually, I was not agriculture man. So what we are observing that it was roughly about month of February, March, the leaf becomes yellowish. Obviously, when the leaf becomes yellowish, then we got things are not going too well. So why it has happened? Because in a greenhouse, when you want to heat, it should be airtight. So in the case of airtight, because if you have just ventilation, then temperature go down. So in the airtight, what happens? The plant needs carbon dioxide, just like us. We consume oxygen, discharge carbon dioxide. The plant consume carbon dioxide and discharge oxygen. So in that case, we are not able to understand why it is so. It's a disease and something like that. But we finally got that due to lowering the level of carbon dioxide in the greenhouse, it is not going to give the optimum carbon dioxide to the plant. And then what we started, we simply did, we just burn the cow dung cake, put inside the greenhouse, then this problem was solved. Sometimes, unless you don't have the experience, but if you do it, then things comes out required. Now just see, I just show you, we have cucumber produce also. Now just to say that only cucumber is outside. Same yield, same sowing, but survival of the cucumber outside was not. But inside, just see how safe, in the shape also, in the taste also it goes. So how you can produce this one. Let's see, we also did experiment that what can be the maximum weight of. So we have got a cucumber of 800 gram. And for kind information, we don't have any test facility, but the taste of all the cucumber which was produced in the greenhouse, starting the beginning, was very tasty. Not I'm saying that because in ADIT we cannot sell the cucumber, but to distribute the cucumber, the department, dean and director and other things, and we got the report that the cucumber taste was very nice. And the perception is that the things which you produce in greenhouse don't have taste during off season, but it is not true. What we have observed. Also, we have produced the temperature control, means the outside atmosphere. And when it says the greenhouse, microclimate, it is inside. Just difference between these two. So these three vegetables were produced inside the greenhouse. Now, just here I want to tell you there are 4 parameters in addition to the root media. In the root media, for all these cucumber, capsicum, we have taken, you can say the 40% soil, good soil, 40% sand and 20% fertilizer. So that was the equal distribution for the outside as well as inside. In a field cultivation, we have not maintained this one because it is totally, you can depend upon the, you can say the soil which is available with the fertilizer. So there are 4 parameters in addition to root media. Temperature is a very, very important parameter for any crop, any plant. And because of that, you may see that the crop which is produced in the south, in the same environment is not maintained as it cannot be produced. Vegetable also seen in a summer, some important vegetables are there, but this cannot be produced in winter. Greenhouse role is this, that you can produce the summer crop in the winter to get the high return. So for that, temperature plays a very, very important role. And that temperature is controlled by solar intensity. Because unless there is not solar intensity, greenhouse effect cannot be applied. And hence, temperature cannot be maintained. As far as relativity is concerned, for human being, the relativity, comfort range of the relativity is roughly about 50%. But relativity, high relativity also plays a very, very important role for the plant, which gives indirectly cooling effect. So it should be at the range of 70 to 75%. Because when you are irrigating the field for particle, any vegetable productions, so obviously water evaporates and the relativity above the plant becomes 70 to 80%. So these are the 4 basic parameters. One should, now a modern technology, You can have a sensor of temperature, you can have a sensor of CO2, sensor of intensity, relativity, and also if the CO2 level goes down, there is a CO2 injector coming nowadays, you can attach that one. So then the production will be more. And for your kind information, to use an injector, you don't require much electrical power, but small electrical power can use this one. This I have already mentioned about this thing. Just I will coming for the aquaculture means fish production. And as you know that there are 4 parameters which I mentioned for the plant. But the plant is also a living, you can say, organism. But it cannot move like fish and human being. So just see, for human being, oxygen is important. Similarly, the fish also oxygen needs. So there is a need of injection of oxygen. And temperature, obviously, if open pond, the solar radiation is utilized to heat the temperature. Also, relativity is automatically high because there is a water surface which is increasing the relativity inside the greenhouse. Obviously, this is a project from ICR. So what we did, and the objective was to see the growth of the fish under 4 conditions. 2 conditions was that our cylindrical tank should be buried inside the greenhouse, under the ground, and another was the cylinder, water cylinder of 1,000 liter capacity should be above the ground, but is within the greenhouse. And outside, again, 2 cylindrical water tank, 1,000 and one is 500. So in that case, we can see the effect of water depth outside is concerned. We can also see the effect of underground tank and the outside tank within the greenhouse. 4 conditions we did the experiment. Now, also to see the growth, so you have to take the fish out, and this after taking the fish out, we have the potassium permanganate K and MnO4. Potassium permanganate, it is a reddish color. So if you just put fish in that, so in a solution of water, so it becomes unconscious. So very easily you can measure the length, because to measure the length for the fresh fish is very difficult because they jump here and there. So this is the way how we measure the fish, size of the fish, and weight also. Let's see the treatment we are giving fish so it becomes unconscious, then you can measure the weight and everything. Because unless you not do this treatment, to measure the length and weight becomes very difficult, because they jump very frequently. To control it very difficult. Yes, what I have talked to you. This is a 2-cylinder tank. One is right one is 1,000, and this is a 500 liter capacity. Here also 2 tank. One is inside ground, and other is, you can say, the above the ground inside the greenhouse. One thing I want to tell you, that in a solar thermal system, if you are improving the efficiency of, you can say, 2%, 3%, 5%, I think one should not go. But in the photovoltaic system, to improve the efficiency of 0.1% is a very, very big achievement. Because here thermal is a low technology and the photovoltaic is a high technology. So this thing got to be very much clear. So we measure all conditions, and compared to the outside of 1,000 liter, we found the maximum growth of the fish was underground cylinder tank inside the greenhouse. Reason being, first reason is the temperature. Because this buried tank gets the thermal energy from underground heat source, which is called the earth storage, thermal storage, and second, due to the greenhouse effect. And the improvement maximum was 25% growth. And whatever you call, like above the tank, there can be, you can say, the 15-16% growth, it was, yeah, 18% growth. It was varying. Outside, it was severely affected. Outside, the growth was there was a casualty of the fish outside because of the low temperature in the winter season. So now you can just see the importance of the greenhouse effect as far as aquaculture is concerned. Yes, when we are doing the experiment on this 1,000 liter capacity, now as you might be knowing that when you are doing something work, so everybody तिवारी जी क्या छोटा छोटा fish उगा रहे हैं या कर रहे हैं. So then we decided that why not we should have the big water tank, and in that case we can grow the fish. And I don't take fish and egg, but the fishery people who are working with me as students from Vikas Sarkar and Lopa Ghosh from Odisha, they came from the fishery institutions. So they say that I asked them, is there any fish you can grow fast? So they said, Rohu fish is growing very fast. So if your result is good, so then you can compare, you can see the result. So we did the experiment with the Rohu fish, but the disadvantage is it was growing fast, but they were jumping also very high above the tank. So what happens? Sometimes they fall space between the greenhouse and the tank. So in that case, what happens? Some rats come and then they pick over. Then security guards also know it was very difficult to control that one. So we did experiment, but we cannot succeed completely because of all this, because you need always security man to see whether fish coming outside or put inside, nobody take it and all these things. So it was very difficult to have such arrangement, at least Solangi Park in IIT Delhi. So I will say that unless you don't have a 24-hour monitoring, just like a human being should be monitored 24 hours, not just like 10 hours or 12 hours. So that was the end. Now, this is a classical, there was a very big project in Champawat, which is Uttarakhand. And we got also the same project, but for only the different way small project. But they got their ICR institution, they got big project to compare the fish outside and inside, the area, if you can say this outside tank, inside the ESM. But in the government circle, this is very unfortunate. The person who was looking after this, he was transferred to the another institution. So they never completed the experiment as far as aquaculture is concerned. Now, that is I will just come for the because when we started the pot cultivation, field cultivation, then it was a month of the October, sowing period, end of October, then transplantation in the November. Then funding agency asked, can you see how much long period it can produce the cucumber? So what we have observed, that during the winter period of December and January, it was a very significant improvement inside the greenhouse. But when we were moving toward the February, the temperature inside the greenhouse was very shoot up. So in that case, there is a possibility of damage of, you can say, the plant. Then you need cooling, and as you know, the hot air has a tendency to move up. So in that case, what happens? We have made a roof vent through which the air can escape from inside to outside to control. But this phenomena, roof vent provision, it has acted very well for middle of the February. But when end of the February, temperature was so high that roof vent doesn't work. Then you see, we have made a provision of 1 fan, 2 fan, and then the cooling pad also. So ultimately we found that the fan and the cooling pad consume more electricity than the cost of the cucumber. That means it is not economical. This thing you have to keep in mind, that this system, any solar system which depends on the grid power, you cannot refer it as a self-sustained system. Self-sustained system means the system don't need any grid power to function or to give the air. That is a very, very important parameter, which I will discuss later on. Let's see. This is the inside view of the fan, which we have just shown you. Yes. And the experiment we did, is the ground air collector. See, economics is always in the mind. Is the ground collector can be appropriate to provide the thermal energy to the greenhouse? So we have made a simple ground collector, means anyone who are aware of the riser and header combination, we have made the plastic header and the riser and just connected this to the greenhouse air. And just we have the plastic sheet and the wooden frame, and the surface was blackened and put on this. So we have very new experience in that case, which was very much suitable for the greenhouse heating system. What happens during the daytime, when the hot air of the greenhouse comes through this air exchanger, it was cooled down. Why? Because upward heat loss through the transparent sheet was much more. Then we thought that it was very much worried. We have integrated for heating, but it starts cooling. So if you need cooling, then you can have this provision. But what happens? We have made an observation after 24 hours. In the night time, this ground collector was giving hot air to the greenhouse because ultra energy was utilized to heat the cold air. So in that case, we only use the ground air collector in the night when the temperature inside the greenhouse is lower. Because if the temperature goes down, then the growth and productivity is affected. Now, see another way. That suppose greenhouse night heat losses is reduced. So what will happen? The temperature inside can be maintained. So for that, upward heat loss should be reduced. So we have made a provision of jute cloth and manual covering of the greenhouse you can cover. So what we did, when the in a winter period, noontime, your solar radiation's level is very small and outside temperature goes down. So losses taken place. So what we did, we cover solar radiation even when there was solar radiation, because loss becomes more than the gain. So we stop the gain as well as the heat loss just by covering the solar greenhouse by jute cloth at the very low solar radiation level. So it is another way of retaining the temperature, and you can say this is another way of heating the greenhouse. Same thing we did about this. This is called event type greenhouse. This is the evaporative cooling system. I think everybody knowing the cooler at that time. This greenhouse was fabricated in 2000 when there was no good quality of the cooler available in the market. Nowadays, there is no need of having this cooler. When you can purchase the cooler and you can make arrangement in such a way that it can be fitted into the walls and can be cooled inside the greenhouse, depending upon the volume of the greenhouse. Volume of the greenhouse is more important than the area of surface area of the greenhouse. This is, you can say this, there was a company ambassador cooler, so but it was very expensive. But the material which was used here is the material which nowadays modern cooler is having. So the life can be 5 to 6 years. So in that case, there is smooth flow of the water over it and the cooling is fast. Now, third thing is that drying of the jaggery. Now, this is a very, you can say, heat and mass transfer relation. Even for the cultivation, even for the fish productions, the evaporation plays a very important role. And all these are the low temperature, you can say this. So what happens? We got a project from ICR to study the drying of a jaggery. Whether it is possible or not, it is a very small project. So project was given that whether it is possible or not. So we got a project from the ICR to do this house in a greenhouse. And there is a history behind that because we are already having the greenhouse. So, in a Western UP, you can get a slab of, you can say, jaggery, very big slab, might be weighing 4 kg, 5 kg. So we purchased jaggery from there and we put on the inside the greenhouse. But result was very disappointing. Instead of drying the jaggery starts melting. So we got very much disappointed that how we can succeed this. Initially, it was just, you can say this, and one student was research for PhD for this. So somehow, this start melting. So generally, when you do the experiment, repeated, some mistake happens and then you can find the solution. So what happens, I was in an impression that because crop drying, we have done experiment on the crop drying also. So we found that through the literature, that drying depends on the size and shape of the product. That I was knowing. So first thing I stuck to my mind that why not it should be broken into small pieces and see the effect. So we did the same thing. 4 or 5 pieces was broken. So what we observed, the melting is reduced at that time. Why? Because surface area was increased, so heating was increased, so melting starts. Melting is also reduced. So it came to our mind. Then we discussed with the ISSR, Indian Institute of Sugarcane Research Institute, Lucknow, from where our Dr. Anwar and Alishi was doing PhD. So they helped me. Then I say that just see, you are getting this result. What is the problem? So then said the sir, if jaggery can be formed in a small size, I think dyeing will be better. So what we did, then they mold a dye बनाया हम लोगों ने और shape just see 1 kg, half kg, and even a small rectangular and circular shape. This we fabricated in IIT Delhi. And then we took this to the sugar belt of Western UP and we created, you can say this. And number of the weight wise, we have just put weight wise. If you have taken the 2 kg, the 2 kg rectangles, everything. Then we found that the thickness also plays a very, very important. And size also important role. So the circular shape, which was the least surface area more, but weight less, starts drying fast. When there was no melting at all. Then we decided that we should go for the small size, not for the big size. And the student who left, that's why इसमें तो कुछ रिजल्ट आ नहीं रहा, हमारी तेजी नहीं हो पाएगी. So चौरसिया जी थे NIT पटना में इसमें, he said, no sir, I will do it. So ultimately he got succeeded in doing this thing. Just see, and very important. Size of the greenhouse is also important. That means if you are having the part cultivation, you should save it in a heat capacity. On the basis of heat capacity, you should design the greenhouse. Not greenhouse should be first designed and then decide the capacity. Because every farmer knows how much crop they want to dry. So accordingly, greenhouse shape and size of the greenhouse and material should be designed. So what we did, we just design a very small, just say it is also greenhouse, event type greenhouse, and PVC plastic was used. And one thing here I want to also make clear to every participant, that all solar thermal devices give better performance under force mode. Whether it's a water heater, distillation, drying, passive, anything. That means the solar thermal system always gives better performance in the force mode, and solar thermal system can only work during the daytime, and during the daytime you need electrical power. If there is no grid, no drying will take place because moisture is very high, it is very uneconomical to use. So all this system are not self-sustained. Repeatedly I am saying not self-sustained. And what I'm saying on the basis of 40 years of my work in this area. So don't try of natural circulation. In forced circulation, you get research further, not back to pavilion, like natural circulation. Now I will finish it. You can say this, my lecture in a couple of minutes by mentioning. So, through a literature survey, here I want to make a brief 4-5 minutes about PV system. I will not go much in detail. The conventional PV system, which is manufactured at the large scale, is the crystalline base. I will not go much in detail. I'm just giving you, just believe it, what I'm saying, because it will take another hour to explain why it is so. So, crystalline based PV module is the maximum manufactured globally, even in India. There are 3-4 stages: first wafer, then solar cell, then PV module. I am not a man of wafer or solar cell. We are the man to apply the PV module for our application. So the PV module, if you just see on the top it is glass, then the in between below glass there is solar cell, which is attached with the EVA, and at the base there is a tailor plastic lightweight insulating. That is the conventional PV module, which is manufactured in India and available in India of different size, maybe 75 watt, 250 watt, maximum it is 300 watt peak also, it is 500 watt. But the size totally depends upon the requirement of the users. One should be careful that you should design a device from keeping the requirement of the users, not from your own way. Because unless it is not acceptable to users, whole design is best. So what happens at that time, Central Petroleum Limited made a testing, they might have also seen somewhere else, that in place of the tumbler, they were using glass. And that this PV module, beginning it was a pseudo nature. Pseudo nature means if you join the two solar cell or solar cell, then it doesn't cover the whole area. There is a space left between two solar cells. And when they replaced the tumbler by glass, they found that the replacement of the glass is improving the efficiency, electrical efficiency. And that PV module they refer as a glass-to-glass PV module. My friend Dr. V.K. Kaul was there, manager, and we have very good reputation between the IIT and CL. So they say this problem, that sir, when tumbler is replaced by the glass, its efficiency is improved, but we don't know the reason why it is so. So then I say that unless you will not give us 3 samples to test in our presence, in an outdoor condition, how we can say it. So they given me the tumbler-based PV module and glass-based PV module. We did experiment in the outdoor condition and really found that the current is increasing. Voltage will be always fixed in the all PV system. Only current changes as a function of intensity. Intensity increases, current increases, power increases. I will not go much in detail. So we also thought why it is so. So what we observed, that back of the solar cell, in a tumbler case, there was no solar radiation passing through the PV module. But when it was a glass replaced, then part of the solar radiation was transmitted to the back of the PV module. So click the idea, we write energy balance, we prove that the temperature of the semi-transparent PV module is higher than the temperature of the opaque PV module. That means, and also the semi-transparent PV module has more advantage than the opaque PV module, tumbler-based PV module. And the semi-transparent PV module has many applications. Even a drawing also it has application, greenhouse also is application, and building also. Because first thing is electrical efficiency improves. Second, it gives direct and indirect gain also. And also it gives the lighting, daylighting. Daylighting means plant needs for photosynthesis. So for greenhouse, the semi-transparent PV module is the most appropriate. Why? Because the component of the structural and the life of the PV module is more or less similarity. For example, if you have the greenhouse structure of the aluminum frame or GI pipe frame, if you paint its life is 100 years. And the life of the crystalline based PV module is 30 years. So you have to only change 3 times, otherwise it gives the same performance. That's why if you are having semi-transparent PV module in place of the transparent sheet, plastic sheet, so it serves 2 purposes. First, it provides electrical energy to operate the appliances to the greenhouse. Second, it gives direct solar radiation for photosynthesis. Third, it gives direct thermal energy and indirect energy from the back of the solar steel. So it is also good. So you can use heating along with photosynthesis, along with electrical supply to the appliances, electrical appliances to the greenhouse system. And then you can refer it as a self-sustained greenhouse integrated semi-transparent photovoltaic thermal system. In a short, it is called GISPVT. When in an IIT on the literature basis, when they are talking of this thing, so it was very difficult to convince funding agency that this is the system which exists. But on the basis of the literature survey, we found all these things I have hopefully spoken. Let's see. This is how a cross-section view of the GSPVT. I have shown, I have discussed all the parameters which I have referred you. It is called uneven because the area of the north and south is different. So uneven. If it is same, it is even time. And here, this is the GSPVT, which gives electrical, thermal, lighting for photosynthesis. Again, that is all these things has been. And for kind information, at my hometown Balia, we have got a project on this concept. And in this case, we have considered different packing factor to see the level of solar radiation for best photosynthesis. So 30 kilowatt, 10 kilowatt for 0.9 packing factor, and 10 kilowatt 0.5 packing factor, 0.40 and 0.22 packing factor, 10 kilowatt is, and the area covering is roughly about 80 feet to 120 feet square. So it is a very big project. It is roughly about 2.6 crore. So we are executing in Balia. Construction has already been 95% over. We are going to start cultivation, part cultivation, as well as channel cultivation in the area where the land are deserts. In a desert land, cannot grow. So it is going to give you 3 advantages. First, the land is used for the part cultivation for vegetation. And second, it produces the electrical power. And most important thing that in a harsh weather condition, all the vegetation is destroyed. So in that case, this GISPVT will protect the harsh weather condition outside as far as plant is concerned. Let's see. This greenhouse also uses a photovoltaic integrated in a greenhouse, very big project. This is the end of the project. Let's see. And once we have shown this project also has the different roof vent because if the weather is very hot, so in that case you need more opening so the hot air should escape it and the temperature can be controlled with the help of the sensor. Now they have the most advanced country and their opening and closing is through the automatic. Here, automatic anything needs high maintenance because the maintenance is one of the most important parameter for success of any technology. And if the maintenance is less, demand will be more, cost will be less, and benefits will be more, income will be more. This, I think, this is another, you can say, views of the same thing. Thank you very much. If there is any question, most welcome.
Question from participant.
Sir, good morning. Hello.
Hello?
Can I ask the question, sir?
Why not? Last question.
Good morning, sir. Sir, in India, why this greenhouse solar drying technology is that much not popularized compared to other countries? Because we are having good sunshine in India, still we are, in agricultural sector, still the people are facing the problems in solar drying and like using the greenhouse techniques.
Now, your question is not particularly with the greenhouse. If I remember correctly, that in 70s, there was a subsidy on this solar technology, water heater, cooker, and dryer, everything. But what has happened? जैसे हिंदी में हम लोग कहते हैं कि फ्री में कोई चीज मिलता है उसकी महत्व नहीं होता है. तो सब्सिडी कंसेप्ट वाज इनिशियली इट वाज वेरी बैड आइडिया. First thing. Second, if you want to popularize a greenhouse technology, I will just give one example: water pumping, solar-based water pumping. In Punjab, it is most popular. Why? Because in Punjab, there is a minimum theft of the electricity from the grid. So, by using the water pump, for them it becomes very economical. Why? Because it can take during the daytime and you don't require any battery for that. So if you avoid the battery in the PV system, it is most economical. So in a similar way, if in other states, government is announcing, install water pumping, everybody wants to free. That's the one reason. Second, as far as drying is concerned, same thing is also for water heating. In a water heating, if you just go Israel, go for it is a mandatory to have a water heating system integrated to the single storage building for all the occupant. Here it is not so. So, यहाँ पर अगर कोई नियम बनाते हैं तो आपको सत्याग्रह शुरू कर देंगे कि नहीं भी हम तो अपने मन से काम करेंगे. Third thing, in agriculture, I will assure you that just like a greenhouse integrated system, there is also greenhouse integrated solar dryer under force mode. It is most economical, and you know there are many things which is wasted, and if you dry it, make a powder, make a paste, store it, package it, sell it, from commercial point, it is most economical. But यहाँ पर हमारे यहाँ क्या है कि हर आदमी नौकरी चाहता है, कोई काम करना नहीं चाहता है, तो कहाँ से सक्सेसफुल होगा? एग्रीकल्चर को जब तक एग्रीकल्चर फील्ड में ले जाके खाएंगे नहीं, हाउ इट विल वर्क? हम लेक्चर दे रहे हैं, आप लोग पढ़ रहे हैं, आप लोग सुन रहे हैं, कोई एग्रीकल्चर इसमें इन्वॉल्व है? कोई नहीं इन्वॉल्व है. और इफ यू अंडरस्टैंड one thing, that it is not our duty to popularize. It should be popularized through the NGOs which we are doing here. अब now बलिया में आकर के, remote area में, remote village में आकर के, I am doing this experiment, and people are coming asking, what is the cost? What is the this fund we can get from the government? Unless you not move to the field, no technology can be popular, and you have to prove that. This is the benefits. For example, let's just say that we should increase the productivity, we increase the double income of the farmer. Now, if you are planning throughout year cultivation, including the off-season, pre-season, post-harvesting, then you can increase your income. So popularization is a very, very important parameter. It should be carried out either by government or NGO or by own research method or university and other things. University should take care, you can say this adapted agricultural area, they can go. Now, this, in Maharashtra, I think the haldi वहाँ पर बहुत उगाया जाता है, पता होना चाहिए नहीं होना चाहिए. And haldi को जब तक आप dry, you cannot dry directly. You have to boil into the warm water at 100 degrees centigrade. And then after that to dry and then make powder. Then haldi is formed yellow color. So there the solar system can be used. But they are trying to do, some farmers are using, otherwise they are using the biomass. They are cutting the tree. So to avoid all this type of the deforestation, use this renewable energy, use the solar energy as and where it is required. That's all. Anything more?
Thank you. Thank you, sir.
Okay, bye.
Neeraj Patel, sir.
Hello?
What do you say? Greenhouse is built on terrace. Please give some details. That is the Neeraj Patel, sir, is asked.
What's detail?
Is built on greenhouse on terrace.
We have already built a greenhouse at Banaras. So if he is interested, instead of going to the paper, we have published paper also. If you visit, then you will see how the greenhouse on the terrace has been erected. And in that case also, we have used the semi-transparent PV module. So you just send me an email. We can send our e-paper, paper published. You can send the photograph of the dryer to him.
Okay, thank you, sir.
Now, any question from participant? Okay. Now, thank you, sir.
Okay, my pleasure to you also.
On behalf of Mechanical Engineering Department, ADIT, we like to express our sincere thanks to Dr. G.N. Tiwari, sir, for accepting our invitation and giving your excellent coverage in his speech regarding the greenhouse application for the rural people. Thank you very much, sir.
My pleasure too. Thank you very much.
Thank you, sir.
Okay, bye.
And our next session will start from 11:45. So please remain, everyone.
We will begin our next session in 10 minutes. Okay, so all of you can rejoin